Hi everyone. So this is the problem statement, and it's talk about search in a binary search tree. So what this problem is all about is we have given a binary search it's binary tree, and basically we need to search an element. And if we see that, so let's say for example this is the tree 42713, and it holds the binary search tree property, and also like left element should be lesser than the root, and the right element should be greater than the root. That's the property of binary search tree. And another thing is what we are doing is we are trying to search for an element in this tree. So what we have to do is we need to return uh, the whole subtree where we find that. So that is considered as a root. So here we consider 2 as a root, and we are going to return this. So this is a problem of recursion. So we will be solving this problem using the recursion. Maybe there are different solutions possible. We can use a while loop also to search that will be a memory efficient solution, but we'll use recursion to solve this problem using the log and complexity. So let's go to the code. Yeah. So very first thing is it's talk about that if we are not able to find that value, we are going to return the null. So that's the one condition. Another condition is if we are finding that element, we need to return that subtree. So what we have to write is, so there are a couple of there are a couple of things always keep in mind, like when we are writing the tree recursion problems, we always need to find the edge cases, and also we need to find the cases where like let's say for example for this particular case, what happens if root becomes null. Like we try searching the element, and if we're not able to find, what we should do. So very first condition is what if root is null, right? So if root equals to null, right, I'm just gonna return the null value. Then as like in binary search, like if we have a sorted array and we need to find, what we do is we just go through the loop and just we do low, mid, and high. Similar way we are going to do that, but here we need to find this element called val, right? So what happens if we are able to find the val? So what happens if we find the mid element in an array? So we just return that mid position of that array, right? So similar way we are going to do that. So we are just going to write if root dot val equals to val. I'm just gonna return the root, right? Otherwise what we do is we also write one condition: if val is greater than root dot val. So if value is greater than the root value, then we should search in the right part of the tree, right? So we are just going to say return, and we can write this recursive function return search tree, and then we can just write root dot right comma val, right? Else return this function with this root dot left comma val, right? So this is all what we have to write for this particular problem. It is pretty straightforward problem. So we are just going to find that element, and we are just going to return that particular node as soon as we find that. That's the whole idea. If we don't find that, then we are going to return the null. So let's try to submit this solution. So submitted that. Okay, so it got accepted, and let's see. Yeah, so you can see it's a 0 millisecond problem. It does have taken a memory space, memory uses. We can even optimize that as well. So we can use even that while loop and try to optimize the solution. But for me, I use this recursion technique to do that. Thank you.